Excellent. So there's still a queue on the highway, but we've been asked to start, so we're going to get started. And for anybody that comes in, please grab yourself a seat. 8:30 in the morning, Tuesday, and we're all here to talk about energy codes, so I'm sure people have some questions. We'll get right into the presentation. We've set it up for an hour and a half, maybe up to 2 hours, depending on the interaction. The idea for today's presentation is to talk about NECB implementation. We're going to cross-compare it to a few other things, and we'll talk to some of the items and how it affects business as usual in City of Edmonton or Alberta or other provinces if we get into that. My name is Ghataurah. I'm with AES Engineering, and we'll talk a little bit about the firm and our agenda for today. The idea for today's presentation is to be a bit interactive. So if there's any questions, we can wait till the very end, but if something comes up relevant to what we're discussing, please bring it up and we'll try to address it the best we can. Otherwise, we lose sight of the question, and at the very end, it's usually the rush to get to the next seminar. So any questions, please feel free to interrupt, and if there's a group of them, we'll try to combine it and speak to it all at once. Please help yourself. There's a lot of room on this side of the room as well, so grab a seat anywhere. The agenda for today that we'll talk through very briefly, we'll talk about our story and what AES is all about. The firm's been around for 16 years and a bit about the background. And energy, whether it's a standard or a code. And a lot of folks have that confused. Why is that important? Why does it matter to know whether NECB is a standard or a code? And we'll get through some of that as well. Code adoption and the scope around the code itself. Lessons learned from BC. We're in Alberta. Does anybody here practice outside of Alberta? There's a few folks that practice outside of Alberta. That's great. So we'll talk about some lessons learned from Ontario as well, and then BC especially. Why I picked BC? I was from BC, and now we're in Alberta. We've been here for the last 2 years. BC, we've been practicing energy standards and codes for the last 25 years. And there's some really good lessons learned from that we could share with the group. Compliance forms. So we have to fill out some more paperwork. And any more paperwork in our business is usually painful. But trust me, this paperwork is actually a good thing. It takes us back to the way we did business before business got accelerated with doing it much faster, quicker, and of course, everything else gets squished in there as well. City of Edmonton specific, so if we're doing a project in the City of Edmonton, city requirements, what does the city require, what does the authority looking for when you're submitting for permits, and then of course, occupancy. So occupancy permits are no longer the same as what they used to be before. Industry trends, very brief touch on industry and some of the items around LEED. What's new in NECB? So we'll talk about mostly from an electrical perspective. We're a Div 26 firm, but we'll get into some of the envelope stuff, mechanical as well. So again, if there's some questions, please bring it up. Why does it matter? So we've been doing it without this for the last, I don't know, I've been practicing for 25 years. Others may be practicing for 30, 40 years. Who cares? Why bother changing now? And we'll talk about that as well. Alternate compliance, there's usually an alternate compliance. There's always an option A or an option B. When we brought the code into adoption in Alberta about 2 years ago, there is only one option. There is no option B. We're working with the regulators to look at providing a second alternative, but that's not going to happen for a few years. So NECB is here to stay. So moving forward, what are the next steps? So we'll get right into it. My background, before we talk about the firm, started with AES in 2008 at the height of the boom, a month before the crash in our real estate market. I joined AES and opened the office in Vancouver, and then we'll talk about the rest later. Prior to that, I worked at Stantec, and we led the commercial group out of Alberta and BC. Prior to that, I was with AES Engineering, and we did a lot of the sustainable projects, and we wrote the book around LEED, working with the other consultants. Before that, I worked in pulp and paper, and prior to that, I was an electrical contractor for about 7 years. So I started my journey in this industry in 1993. Bit about the firm itself. So we're a Div 26 firm, if Div 26, 27, 28. If it's powered, it carries a pulse, we do it. If it's wired or wireless, we do it. Electrical, lighting, communication, security, audiovisual, and other technologies. So other technologies are items like code consulting, code reviewing, interpretation, acoustic modeling, daylight modeling. So we get into many, many other renewables is another big one. So we'll talk about some of that as well. The firm itself started in 2001, and it's a bunch of ex-colleagues that worked at a firm called Ghataurah. and everybody in Edmonton knows of Reed Crowder. The other main electrical firm was AES Engineering. Reed Crowder sold the practice to EarthTech in 99, shut down a few offices. One of them was in Victoria, and the firm started in May of 2001 with a group of about 10 to 12 individuals. I joined the practice in 2008. We've now got offices in Vancouver. We're about 60 people in Vancouver. It's our main office. An operation on the island at 20 some odd people. We're in Calgary. We're 7 staff in Calgary, and we're ramping up to 10 probably by summer or spring or fall this year. And proud to announce grand opening of our Edmonton office this morning. We've just opened practice in Edmonton, and I'd like our team to stand up real briefly, and I'll probably do a quick introduction. So if everybody from AES could quickly stand up, I'll introduce our group. And if you've got a noise-making device, if you could kindly put that on vibrate or silent, and we can have less noise-making. So I'll start with a group here. Lady in the middle, Trina. Trina is our new partner on board to run our Edmonton operation. Prior to this, she was 12 years with Dialogue. Prior to that, she had 6-7 years with Keen. And before that, she was on the client side. So she's a senior electrical engineer that's with us, running the practice out of Edmonton. Amir up front. Amir was brave enough to move out to Alberta 2 years ago. He started our practice in Calgary, and he's now in charge of Alberta. So he looks after our operations in all of Alberta. Over in the back there, the gentleman with the beard. He's Barinder, and he's new to Calgary. He moved out about 4 months ago. And he leads up our special projects. So ASHRAE, NECB, MNECB, all the implementation, working with authorities having jurisdiction. He's helped us guide that process through BC, and he's now going to work with our team in Alberta to take care of that as well. Up in the corner here, Eki. Eki is our principal, and he also looks after the operations in our head office, so I can get to travel and live in airports. Gentleman in the back corner, Kevin Chung. He's one of 2 individuals that sits on every committee that either writes codes or interprets codes. He also leads up our healthcare division. And prior to joining AES, he worked with Stantec, which is where we work together. And he was the engineer that designed the expansion for Edmonton International Airport before he left and joined us in 2011. Gentleman in the very back, Roger Dupuis. Roger is actually the founding member for AES. He started the practice in 2001, and he now runs our operations in Victoria. And very, very happy that he could join us here as well. And then last but not least, Mo Khan. So Mo comes to us from South Africa. He's been with us for about a year now and practicing for the last 3 months. And his main focus is renewables. So back in South Africa, energy costs anywhere from 30 to 50 cents a kilowatt hour. So it's all about getting off the grid and going PV or trigen or cogen or going into other scenarios with biomass and biogas. So Mo is on board as well, working with Amir to do our renewable deployment into Alberta. So thank you very much. And any questions, the folks are here afterwards to answer for you as well. We're about 90 staff, and we cover the Western region. And the growth that we're looking at is not growing for the sake of growing. The growth is mainly because clients are calling us. Edmonton was something that we weren't really, wasn't on our radar about 3 years ago. But 3-4 years ago, when the authorities started calling us about implementation for the codes, help us write it, help us interpret it, and a few developers and clients as well. So we're proud to be in the city, and thank you for having us. Some of the credentials I'll talk about. Architectural lighting design, and architectural lighting design is not necessarily just foot candles and picking out fixtures. So when we work with architects, it's working out and creating an architectural concept of integrating lighting into either the wood or the ceiling or the building itself. So it is very different than doing traditional foot candles and light level layouts. This is where we work with you to define your finishes and your colors. And yes, engineers are going to get involved in finishes and colors because we need to change the colors and the reflectivity in order to meet the lighting levels, in order to meet code. And if we don't meet code, we're not getting a building permit. If we're not getting a building permit, might as well go home. We're not doing anything. Communication, security, and audiovisual. There's 120 people registered for the seminar. There's probably 120 or 125 of these because some people have 2. I don't know why, but some people have 2. We live and breathe by this. It tells me where to go. It tells me how to get there. Why I point that out? With automation and integration, tracking devices, mobile tracking, big data, the focus of communication, security, and audiovisual has traditionally been an afterthought. We design the building, we put the furniture in, we do the FF&E, we finish the programming, we get all the systems done. All right, let's get in the other consultants, the audiovisual, the communication, and the security. And it's actually not going to work or suit us properly going forward. We've got a customer. Bentall Kennedy is the developer for a tower in Vancouver. The owner requested something different. We presented a different solution, but it caused us to design the building differently. We designed it with infrastructure up front and the low tension up front. Then we did the architecture. Then we were working with them on where to put the scissor stairs because that's going to affect the core and affect the distribution on the floor. Now their tenants pull up. Before they come to the garage, we pick up the signal on their car, which is basically their smartphone. The garage door opens. As they drive to the parkade, the lights come on like a runway. Their stall that they've got a reserve sign on is lit up, ready for them to park. Before they get to the lobby, the elevator's already there with destination dispatch. We take them up to the top floor. They go and sit in their private office, and the lights and air come on as required. It sounds like the Jetsons, but it's actually very doable. That building we designed was in 2009. It opened about 3 years ago. You have to look at designing a little bit differently in order to integrate. And if we do that properly, we can actually use the lighting and the sensors in the lighting to take away HVAC sensors and other devices that we've got on the wall. So a bit of change on that. Sustainable design, I don't have to preach. I think everybody is very familiar with LEED and then some of the other rating systems like WELL, Passive House, and Green Globes and many other rating systems that we work with. You're leading or you're not. Western Canada, you're doing LEED projects. The very last one, the ULC standard, the CE code, Canadian Electrical Code, National Electrical Code, any code standard, a reference document that's written in North America, Canada or US. We have either chaired it, we've authored it, we've edited it, or we've modified it, or we interpret it on behalf of the authority having jurisdiction. Kevin Chong in the back, and the other gentleman with us is the chair of the Canadian Electoral Code, Art Tisserov. So the point on that, if you're having a challenge with the city or the authority having jurisdiction in interpretation of some document, and there's some red tape going on, give us a call, and we help remove the red tape. So that's where we influence quite a bit, things like elevator codes and other codes that are out there. We're also the consultant to the authority having jurisdiction, so Alberta Infrastructure, City of Edmonton, City of Calgary, safety standards in BC, and every jurisdiction in BC as well. We help them on BC code interpretation, electrical code, energy standards and codes, and safety standards as well. So very proud to be a part of that. This one I'll point to very briefly, because every architect in this room, oh, by the way, I never really asked, by just show of hands, how many architects and designers do we have in the audience? That's about half the room. Any owners and developers or direct owners, landlords, institutional clients? Yeah, a few. Okay. And the remaining would be any contractors, suppliers, any engineers? Okay, excellent. Mechanical, electrical, a bit of everything. Great. So I'm sure you've got a copy of the Canadian Electrical Code sitting in your office library. If you open the very top, right at the beginning, the chair of the CEC 2015, we chair the Canadian Electrical Code. So quite an impact on delivery of codes and standards. A few projects that I'll put up, and then we'll get right into the presentation. This is the Student Union building at UBC that we won the award at AES International for. Very proud of this building. If you have a look at it, it's a grand atrium space, 25,000 square feet, 5 stories tall. There's no hanging lights. You won't find a single fixture other than the Louis Poulsons in the bottom right corner, just because Yost wanted some Louis Poulsons on the job, so we found a spot to put them in. But really, all the fixtures are integrated into the millwork, into the wood, and we found a way to provide illumination in the space by illuminating the space and creating the lighting effect that we had wanted. This is Guildford Rec Centre. It's a project that started with a very healthy budget. 10 years later, council approved it, so you know what happens then. We basically have the budget of a Costco, and we have to design an aquatic facility. So you remove all the windows, remove all the ceilings, you go with trusses, and you go with very simple systems. So we worked with the architect in designing a space, and this is Bing Tom, God rest his soul. He'd asked for a space that provided a feeling of zen. So a white box with a contrast ratio of 2:1, vertical and horizontal. So we won the Award of Excellence on this one at IES as well. So on the lighting realm, we get quite involved. Vancouver Aquarium as well, another project we're very proud of. A lot of publications we get involved in. Many folks in the office author many of the documents that we publish out there. And we speak about either codes, interpretation, or what's going on in industry and industry trends. So we try to get quite involved, and we're quite active in the organizations. We speak a lot at BUILDEX. So Edmonton, Calgary, Vancouver, and we get quite involved on the real estate forums and the BUILDEX seminars themselves. This one's a new one. So and I'll reference BC first, and I'll get to Alberta. In BC, we've had this introduced, so ASHRAE and NECB 2011, we've had them introduced since 2013. So it's almost 4 years we're coming on. And there's still a lot of challenges in the industry where people at the authority having jurisdiction do not know what to review. We have engineers that do not know what to design. We have clients that don't understand how it affects their projects. And we have owners that don't understand the implications. So we created a course at the institute there called BCIT, which is similar to NATE in Edmonton. And we teach and we train anybody that takes a course. The people that come to attend are competition, contractors, and inspectors. We ran it once in September of last year. They loved it so much. We're running it again on April 28th. And we're in discussions right now at SAIT to run it at SAIT in Calgary. Something similar to this, but heavy focus on NECB. And we're looking to do the same in NATE as well. The other two we get quite involved in with IDI and with AIBC and the AAA. We're hopefully speaking at AAA Banff session at 2018. And we're also speaking at the energy session for AAA in May, on the 9th of May. Please come on in. There's a lot of room on this side of the room. Feel free to walk through. So, energy. NECB. Anybody here work with ASHRAE at all? Because LEED, until recently, you had to use ASHRAE. Or is everybody here only NECB? I see some nods, so some folks have worked with ASHRAE on the projects in Edmonton. Codes or standards? Have a look at the three that I've put online. LEED, Green Globes, and LBC. Are these codes? Are these standards? What are they? It's 8:30. We're trying to make sure you're awake, so. Standards. Architect? So these are actually standards. They're not codes. A lot of folks speak to them as codes. These are standards. They're rating systems, actually. Within the rating systems then go and reference other standards. So if you look at LEED, LEED references ASHRAE 90.1, 55, 62, thermal comfort, indoor air quality, and many other ones as well. But there are rating systems that reference a standard, and we go and apply, we do a design, somebody goes and verifies, we get a scorecard, and then we actually lost or won, and when you won, it's either silver, gold, or platinum. The next one, Green Globes. Anybody use Green Globes in Edmonton? No? So Green Globes is another rating system, and if you're working on a project with public works, so federal projects in Canada, they're no longer using LEED, it's only Green Globes, and that's the only standard that they're going to be using on all their projects, whether it's a base building or a fit-out. That was implemented about 3 years ago. And the last one, Live in Building Challenge. If you've heard of LEED and Passive House, you must have heard of LBC. Live in Building Challenge is design a building where you are not taking away from the environment in which you put it in. So basically, design a building and have a carbon footprint of 0. And we've got a few projects in LBC. We've got one in Penticton in BC, which has targeted it, and it is LBC certified. The EUI on that one for any of our engineers who like metrics, 65 kilowatt hours per meter square per year at 160% occupancy full-time equivalent. So blows my mind. If you have the 160 out and you go down to 100%, we're less than 50 kilowatt hours. And it's an 80,000 square foot trade school. So it's a trade school, highly intensive on energy. The next one, ASHRAE and NECB, and I'll speak to both of them. We've got folks in the room that design projects to LEED and a LEED rating system. Actually, I should ask. People here actually use LEED at all, or no? We're just implementing some nods? Okay. So the very first one and the second one, anybody identify the main difference in the first and the second? Other than they're two separate documents. That's a good, I haven't heard that one before. Okay, I'll take that. You say code because it's got the word code in it. So no, not really. The first one is ASHRAE, it's an American document. The second one is NECB, it's a Canadian document. So the first one is written for American climate, and the second one is written for Canadian climate. First one is a standard. The way it's implemented and introduced into different jurisdictions is how it becomes a code that's enforceable. Second one's exactly the same. How it's adopted is how it becomes code. Why is there a difference between the two, and why do we need to know the difference between the two? Up until recently, LEED version 4 allows you to do NECB on a project in the City of Edmonton. Prior to this, it was LEED 2009. You couldn't use NECB 2011. So people were applying ASHRAE on a project in City of Edmonton, which is extremely painful to do. And for any nods in the room, yeah, you've been down that path. You do not want to apply ASHRAE in Edmonton. What's the main difference in the first and the second? In America, we're always 30 degrees, right? So we design for California weather. So you're always air conditioning. When you're air conditioning, your envelope has a different requirement than when you're heating all the time. So in Edmonton, anybody know the heating degree days in Edmonton? About 7,000 heating degree days is what we designed for, 6 to 7. Calgary, we're about 4,000. In southern BC, we're about 3,000. Northern BC, we're about 5,000. So we're about 6,000 to 7,000 heating degree days, which means you're heating more than you are cooling. So when you're heating more than you are cooling, you need a tighter envelope. And if there's any architect in this room and any envelope folks in this room, this is for you. The better the envelope, the more successful you are and will be at applying NECB. If you cannot deal with the envelope, you might as well pack your bags and go home. It's not going to happen. You will never pass a blow test. And we'll talk about some of that later on as well. So the very first one, if it's applied on a project in Edmonton, which we've seen quite a bit, we've also, through the CAGBC, we work on what's called the lead police. So when people submit documents, there's an authority that reviews it, and they go out to a few firms that get on the bidders list and review the documents to demonstrate compliance. We're one of those as well. So we review it to ensure that we get compliance on it. And we always see the first one get introduced and implemented on projects in northern Alberta. It does not work because ASHRAE is not designed for minus 40 degrees outside. NECB is designed for minus too much outside. Right? So that's the one that we need to apply in Edmonton or northern BC as well. These two documents, I'm not going to ask, very straightforward. These are actually codes. The very first one is NBCC, and you know, we're here to talk about NECB, and we're here to talk about lighting controls and so on. I'll get into that. That's the easy part of the game. The understanding of the implementation and how you may or may not get caught is the trickier part of the game. So there's projects that go all the way in through DP or BP, and then or going through DP, then they cannot get BP because the interpretation was incorrect. So that's why I want to get through some of this stuff for you. Very first one, National Building Code of Canada. The second one is Alberta Building Code. So we've got the NBC that's developed for the country. Through that, we extract the ABC, which is then used for enforcement in our province. So the referencing two other documents, one of them in BC and one of them in Alberta. I picked these ones specifically because they are very different for the application of Part 10. So in Alberta, we've got Part 3 and Part 9. I do have some slides on Part 9, and before I get into that level of detail, is there anybody here that does design Part 9 buildings, or is everybody a Part 3 building? Okay, so we do have some Part 9 folks. Fabulous. So I've got a few slides on there. The most important document you want to pull out if you're a Part 9 building is Appendix A in the back, Section 936.1.3. Memorize that table, make it your best friend, because otherwise you will be applying 9.36 to a building that's not applicable, and you must apply NECB to it instead. And you'll find out about it too late in the game. So we'll reference that later on as well. So on the left, you'll see Part 3 and Part 9. Part 3 is any building 600 square meters and larger. Anything smaller than that falls under a Part 9 category. Under BCBC, we've got the same. We've got Part 3, Part 9 as well, but we also have a Part 10. In ABC, Part 10 is temporary homes, temporary lodgings, temporary structures. In BC, Part 10 is the energy code that gets referenced within that document. So within the building code, there is a reference directly to ASHRAE and NECB, the two codes implemented in BC. In Alberta, there is no reference to NECB within the building code. So, for the folks that want to get out of jail card, if you're applying for a permit in an authority having jurisdiction, let's say not City of Edmonton, let's pick a smaller city, and you are only pulling a permit against ABC, you do not have to comply with NECB because NECB is not referenced within the ABC. And we'll talk more about that shortly. Code adoption and scope, if everybody's seen this bulletin from Safety Act, yes? Wait 3 slides and then you'll get to the point I'm going to make. Yeah. So building safety codes and building code regulation, if everybody's seen this document, when you pull out a permit in the province of Alberta, when they grant you a permit, they grant it against codes that are being enforced within the authority having jurisdiction. So the very first one on the left there is the Alberta Building Code. Item number 1. Item number 2 is 9.36. Very straightforward. Parallel to that is NECB. So when you pull a permit out, and you pull a permit out from the authority having jurisdiction, which is granted permission from the province of Alberta to issue a permit, they're issuing you a building permit that you are now going to design and construct in accordance with ABC. NECB is in parallel to that. So although it's not within the actual document itself, because it's adopted in parallel to ABC, you must comply. It's a very subtle difference, but it's a very big difference. Because when I pull out a trade permit, well, does a trade permit get a building permit or just a regular trade permit? So then if it's a trade permit, do I need to comply with NECB or not? You see how you can find ways to get creative on projects? And so it's very important to understand that when you're pulling out a permit anywhere in Alberta, you're applying for ABC, you're getting a permit and you're complying for NECB in parallel with ABC. Very, very important distinction to make. The next page talks about when the codes were enforced, and this is history. It's about 1.5 years old. So May 2015 is when the adoption, or it was effective. November is when it was supposed to be enforced. A grace period was given for 6 months, and then they decided to line up the NECB enforcement with Part 9.36 and make it all November 1, 2016. Very simply put, if you're going for a building permit today, you are complying with NECB 2011 or 9.36. If you so choose to go down the path of ASHRAE because it's a lead project and I want to do 2 or 3 paths, go for it. It's just a little more intensive around how you're going to demonstrate compliance. Code adoption. In the province of Alberta, we have 2014 ABC. Within ABC, we have 9.36. So if you look at how the codes are enforced and brought around, we've got the IBC, International Building Code, from which we extract the NBCC. NBC, not the last, but the last enforceable version was 2010. From 2010, we took that document and we created NECB 2011. Because big buildings are easy to deal with. Small buildings, including single-family dwelling or a group a 300 square meter Group C occupancy building is not as easy to deal with. So 9.36 was created later on, and when when ABC was updated for the new release in 2014, 9.36 was adopted within the ABC. So that's why there's 2 separate documents. One is for small buildings, and the NECB is a completely separate document. The first one's easy, comply with building code. Just like we comply with handrails and minimum washroom counts and insulation levels and so on. The second one is not so easy. And why I say that is the compliance forms and project verification changes a little bit. Anybody here done a compliance form for energy? No hands? Really? Even down the ASHRAE path? And the NECB path is so new that you have not done a compliance form? Anybody gone for a permit or anybody gone for a permit since November 1 and done a compliance form? Okay, maybe 2 or 3 hands. Compliance forms are the new best thing for engineers and architects. And at the end of this presentation, you may agree with me. Right about now, you're ready to shoot me. We'll talk about it shortly. The code adoption and the code scope that we have within ABC, I want to talk about the scope and the scope gaps because there's a big scope gap between NECB and then, of course, 936 as well. So there's some loopholes. But the Province of Alberta and the City of Edmonton and City of Calgary have closed some of those loopholes. And there's another one left, and we're going to look to close that shortly. So within the ABC, the scope of work is Part 3 building and Part 9 building. Gentlemen, there's a lot of room out over here. Please feel free to have a seat. Additions to buildings are within the scope of ABC. So if you've got a building and you want to expand horizontally or vertically, that's within the scope of the building code. If I'm doing an alteration, so I call it alterations. Some of our folks like to call it tenant improvements. Tenant improvement is broker talk for the exact same thing. Alteration is a legal language. Tenant improvement is not a legal word. The only thing that's excluded within the ABC is a farm building. In parallel to that, we have to apply NECB. Now, if you look at the scope of NECB scope is a Part 3 building and addition. Part 9 buildings and alterations or tenant improvements do not fall under the scope of NECB. So when we work in a province like Ontario or in BC, if we're doing an alteration or if we're doing a Part 9 building, we have to jump into an ASHRAE model. We cannot use NECB for that purpose. In Alberta, there's an interpretation provided by the authority having jurisdiction on NECB implementation on Part 9 and on alterations as well. And we'll talk about some of that as well. So Part 9 building right now, if you've got a Part 9 building for within Alberta, you're going down the path of ABC 9.36. If I've got alterations and tenant improvements, if the tenant improvement is being done to a building that was originally constructed to NECB 2011, you are doing NECB 2011 for all future TIs or alterations. If it's a building that was constructed prior to, so I've got old product, I've got a lot of that inventory on Jasper Avenue, beautiful buildings, but they're built prior to November 1st of last year. Any future tenant improvement or alteration does not need to comply with NECB. Major addition, yes. Adding a mezzanine exceeds 100 square feet, yes. By the way, by choice of or show of hands, how many people prefer imperial? Because I have some examples. Oh, and I'm assuming the rest is metric. Really? How many metric? Oh, wow. Awesome. We should be metric, but I never get that many hands. Okay, we'll continue on metric, please. There's lots of room out here as well. So we'll give some examples. So on the mezzanine example, it's 10 square meters if you're expanding on anything more than that. This chart is really to show you the different codes and when they were enforced in different parts of the country. So we'll start with the very left, it's the NBC, and then on the far right is the NECB, in the middle of the fire codes and plumbing codes. The very first province to adopt the NECB 2011, or the ASHRAE counterpart, was BC. It was brought in 2013 in spring, and it was executed in December of 2013. 3.5 years later, we still having a lot of problems with the exact same implementation. BC, by the way, has had energy codes since 1989. I started in 93, so I go back to about 1989 is when it was first referenced. So approximately 25 coming on 30 years that the codes have been enforceable within BC on energy. We've just gone from a level 7 to a 9 or a 10. In Alberta, we've had no energy codes. I mean, I did projects in Edmonton. We've done stuff up in Fort McMurray. Well, they comply with different codes completely. We did the Suncor plant out there, and we've done lots in Calgary as well over the last decade. And there hasn't been anything. And now we've introduced NECB 2011. So the difference between the provinces by comparison, and we'll get into some examples, is they've gone from level 7 to 9 on implementation or threshold of difficulty. Here we've gone from 0 to 10. There is no middle step. So we've never done it, and now we've just got to go and enforce it. So business has to change drastically. Other provinces have adopted it as well. And Alberta, we brought it in 2015, and with the 1-year extension. For City of Edmonton, we're in Edmonton, so we'll talk specific to Edmonton. When we spoke at BUILDEX Calgary last year, we spoke about Calgary. If you go right on their website, they have done a fabulous job of describing how to submit for permits. Calgary did it about a year ago, and they've got an energy manager there, Mr. Justin Poker, and he's done fabulous work, working with lessons learned from how it went there and how it went in the city of Vancouver. In Edmonton, we've now deployed it as well, and we've got everything right on the website. So if you go right on the City of Edmonton website, or if you can't find it, Google City of Edmonton Energy, And the first thing that will come up is NECB implementation. What do you need to do for 9? What do you need to do for 2011? What do you need to submit for permits? How do you go about getting inspections, so on and so forth? Everything's right on there. Very easy to find. This is an old slide. I don't think we need to talk about it, but the implementation was November 1, 2015, with a grace period of 6 months for NECB and a grace period of 12 months for 936. They've just extended everything to align it with one period of implementation for energy code. So anybody that's doing a project now, you are complying with NECB or 9.36, period. The exception to that is if you have a development permit that may have been issued to you 3 years ago or 2 years ago or prior to November 1 of 2016, and the DP has referenced a base code of prior to NECB being enforced, that's the code you work with. So if you've got a DP and the AHJ has given you a DP at a certain time period, have a look at whatever codes were enforced at that time. Provided they're not retroacting it till BP, which they can do, which many jurisdictions have done, and we've been surprised by that as well, you are okay. Otherwise, you're complying with today. And frankly speaking, if you're developing a product today, you want to comply with everybody else, because then your building that's new and shiny has the same bells and whistles that every other building has that's being constructed today. So I'd encourage you to look at it a little bit differently. This is, again, compliance paths that I've talked about earlier. So some lessons learned. We go back to about a few years ago. In BC, the energy code that they referenced was MNECB. So if you're familiar with NECB, prior to NECB, it used to be called Model National Energy Code for Buildings. We just dropped the M and called it NECB. That's in the revised edition of 2011, and then the further revision in 2015, which we're now implementing in our office, NECB 2015 and ASHRAE 2016. That's actually what we work with. So BC, we had ASHRAE 90.1 2004, and the City of Vancouver had 2007. And what would we do is we would design projects, we'd submit it for permits, and it's a traditional method of doing projects. Rush, 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 rush. No decisions get made, or some decisions get made, or decisions get modified. Eventually, changes get made during design, changes get made during construction. We're all smiling because it's not new to us. And then we end up with a product at the end that may not have matched the design intent when we went in for permits. Sound familiar? So back in 2007 and 8, we worked in creating a group with the City of Vancouver. And we said, has anybody policed to make sure that everybody has designed and installed what they said they've designed and installed? Very simple concept. I'm designing a foundation for a structure. You build it to the design spec, and it gets installed to the design spec. Why? Because otherwise the building may fall. I'm designing it to comply with energy codes, and I've put in an air handler, and it has a SEER of 15 or 17, or I've put in a lighting system, and it has an LPD, and I'll talk about LPDs. It's got an LPD of 1, and that's what I've met. At the end, did it actually meet those targets? And usually the latter is not the case. So we went and audited a whole bunch of buildings, and we audited sampling of hospitals, universities, schools, office towers. Office towers were the biggest ones, and tenant improvements, alterations, and so on. And out of the inventory that we had went and did an audit on, about 95% of it failed, did not comply with design drawings. So now you go back and go, why? No one made a mistake. The architects haven't done anything wrong. The engineers haven't done anything intentionally incorrect. Contractors haven't done anything wrong. It's construction happened. So let's talk about construction happening. We have, we rush. We get permits in on a partial design completion, and then we make changes on it all the way out, and then we get IFCs done, and then we're still making changes in the construction stage till the end game. Those changes don't always get captured in the initial permit documents, or we do not always go back and make sure that we haven't screwed up the energy model. Or the window to wall, fenestration to door to wall ratio. You got to count the doors as well. If we designed it to, right now it's 100%, and it's got to go down to much less. If we designed it to 40 or 50%, have we gone to make sure that that has not changed? We haven't done that. So that's what we had concluded out of this study. So what the province and the city had done is introduced compliance forms. So compliance forms are actually changing the industry, and what we're seeing happening in Calgary. because we've got an office here and we've been doing submissions on this for the last year and a half. It is actually saving a lot of time and fees on the design of a project. And then construction, we're seeing projects refuse occupancy because they have not complied with the NECB. Now think about that for a second. You've been doing projects for the last 30 years in this province, and now all of a sudden, you're not going to get occupancy because I've done it a certain way for the last 30 years. The amount of clients that are going to see some pain and suffering. So rather than go down that path, we're suggesting let's look at things a little bit differently. So in BC, what we've done is we've got compliance forms, and we design projects, we submit compliance forms along with permits. So let's take three types of projects that we design. My favorite is my first one. In my 25-year career, I've done it once. 2007, we did a project for Firebag Stage 3, which is the administration complex for Suncor up in Fort McMurray. $200 million complex where we were extracting raw bitumen for getting into Stage 4 and 5. We designed the building. We designed all the complexes. We did the installation. We did, my favorite one, we did commissioning. It actually got done. We got O&Ms. Anybody here see a set of O&Ms? While you're doing the project, not after the project's done. We got the O&Ms. They actually did the training for the operators. So it was lawn work, so I think it was Honeywell that came in and did full training for all the facility managers. It was a requirement from Suncor. We cannot put bums in seats till everybody's out of the building. So we got it all done. We gave the as-built, we gave the keys, collected the last check, we left the site. Beautiful project, designed and built exactly the way, textbook case of how a project is supposed to be done. We completed on time, we made a little coin on the side, owner was happy, and no deficiencies, because we actually did what's called commissioning, which we don't always do on projects for various reasons. If we have to go and buy a car, $50,000 or $100,000, whether it's a fancy car or a Honda or a Mercedes or a BMW, would you buy it before their last final safety check to drive on the road to make sure the airbags are working and the windows and doors are working? No, nobody would. Would we sit in a building even though it's not safe? I think we've all been there and done that. So that's what's changed for us. So that's the first model of doing projects. The second model of doing projects is this, I'm also to blame for this for the last 20 years. We start doing the design. We get architecturally to about 70-80% design. We get electrically to about 70-80%, and then mechanical. So everything life safety-wise is designed and done. We go in for permits. Why? Because we're submitting for permits, and we're submitting for the authority to check against all the design requirements against a code. What code? Part 3 of ABC. What's in Part 3? Life safety, pull stations, bathrooms, number of stalls, exit signs, all the standard life safety stuff. Of course, facade and envelope is dealt with at that time. And then we spend, while they're working on reviewing our permit drawings for the next 3 or 4 months, we spend the next 3 or 4 months going into designing, getting into detailed design, and then we finally finish. Once we've issued for tender, then finally somebody gets sign off and the interior designers get on board and we sign off on the furniture plan and we finish all the finishes, and then we go back and issue IFCs. By the time we get a contractor on board, we've got a permit in hand and we start with a shovel in the ground. Very familiar concept. We've gone in for permits on a 70% set. At the end, it gets even more fun at the end. So at the end, when the project's complete, we want to go for occupancy. What is done for occupancy? Life safety. Pull stations, fire alarm, exit signs, handrails, anything to make sure the building is safe to occupy. Between life safety and project completion is O&Ms, commissioning, detail, balancing, right? The biggest complaint around mechanical, it's too hot, too cold. Well, never got balance, it never got commissioned. Lighting, it's too bright, too dark. That's because the sensors weren't calibrated. So we designed it for 30-foot candles and it's 50 here. So the dimming hasn't been set properly. So none of that gets done. And that gets done afterwards. So then we issue occupancy schedules and we issue provisional schedules. Anybody here issued a partial occupancy schedule? That's actually getting phased away. So we've worked with the Electrical Inspectors Association of Alberta and the Alberta Infrastructure as well. And in BC, it's completely removed. You do not get partial occupancy. You do not get provisional schedules. It's final and complete, or don't call the inspector at final. And that's coming to Alberta. It's actually standard practice in California, standard practice in Ontario. We do not issue partials because partial means project's not complete, no bums in seats. And then the third one, it's actually even more exciting. If you've done a project around the KIP funding 6 years ago, Knowledge Infrastructure Program, or now the SIP funding, where government grants are issued and the project must be designed and completed in 18 to 24 months, that is even more crunched. So the project gets in, the design happens the way the design happens, completion happens at construction, or construction gets close to completion, and life safety is not done. We don't have life safety finished. Fire alarm is not working, so we've got fire watch, we've got some temporary approval from the AHJ to occupy the space, and then we spend the next few weeks and months completing the project. This is standard. We've all done it. We're just as guilty because this is what the construction industry has gone into. That is no longer acceptable. In order to demonstrate compliance with building code that I've built a product that complies with code, you comply with everything within the Alberta Building Code Part 3 or Part 9. I think everybody here will agree with that. You also have to demonstrate before you issue a Schedule C that you have complied with NECB 2011. In order to demonstrate compliance with that, I need commissioning. So the construction schedule and methodology on projects has to change. And we've seen it change in other jurisdictions, and it's a blessing. Imagine walking out of a job site and you're done, rather than spending the next 5 or 6 months and you're working with the same architect. Did you get the O&Ms? Did you finish that job off? No. Are you making any money? Well, that stopped months ago. Okay, well, so then why are we continuing to do this? Because we just do it because we want the next job and everybody just does it. And this, with the compliance forms requirement, has helped us change that process. So what's changed and what's going to change in Alberta? And we've seen it in Calgary, and I'm suggesting the same in Edmonton. When we design a set of drawings, we are submitting a set of drawings that demonstrates we have complied with building code. No disagreements. In addition to that, we have to design a set of drawings and demonstrate we comply with energy. How do you demonstrate NECB compliance if the lighting's not done? And why isn't the lighting done, Sonny? Well, the interiors aren't finished. And I need the reflectivity because if it's this carpet, it's about 12% reflective. If it's light and gray, I can get 40. If it's white, non-glossy, I can get 60. And the higher the reflectivity, the lower the foot candles, the lower the wattage. The lower the wattage, then it means it offsets the mechanical, because mechanical's counting on the higher wattage because it gives them more heat and watts in the space. Now they have to offset it differently, and the glass ratios have to change. So you have to demonstrate compliance with all of that at building permit. You're not going to get a building permit. There's a lot of people that are sitting in queue. You're not going to get a permit until you demonstrate compliance with NECB. So then I get this next one. Well, we're not going the prescriptive path because we've been told don't do that, go performance path. Okay, we'll talk about that. Performance path, for anybody that's not familiar, means energy model. Who here, other than the mechanical engineers in the room, I know there's a few, can read an energy model? How many people can read an energy model if you're not a mechanical engineer? I'm an electrical engineer. I do not have the intelligence to read that document, trust me. And we're expecting everybody here to read that document. Who at the city can read an energy model? You now have to demonstrate that this works. So it's not going to work by blindly submitting an energy model and I'll just get my permit because well, that's what you do. It doesn't work. You have to demonstrate compliance. So for the architects in the room, I love curtain wall just as much as you do, but curtain wall ain't going to work anymore. Curtain wall, 100% glass, not going to work. You're just not going to get a permit. FTWR ratio prescriptively, so if you want to comply exactly word for word with what's in NECB, you're about 30%, 30 to 33 maximum. Calgary, it's about 32.7 precise science, and then in Edmonton, it's about the same. R values on the exterior, prescriptively, effective 27. On a curtain wall, can you get R27 on a curtain wall? Okay, then clearly the answer is no. Can you get an R10 on a curtain wall? No. If you can, you should get a Nobel Prize because we just reinvented physics. You're not getting an R10. And if you put that on your drawings, the city is not stupid either. They know you're not getting an R10. You're about getting no more than an R3 or an R4. If you're really lucky, it's R6. Where the glass meets the rest, and the way that gets dealt with is where it all falls apart. And unless it's built in the factory and brought in site and assembled, and then again, are you assembling minus temperatures, 0 to 10, or 10 degrees and above? The fastening depends, and the adhesives work differently in different environments. So curtain wall and that complete glass building is no longer going to be accepted. You just cannot meet with the energy codes. If you want to do it prescriptively, you're looking at about a 33% maximum. If you want to do an energy model, you're still at about 40, maybe 50. I very much doubt if anybody gets past 55 or 60% on an office tower, on a high-rise building. If you get into residential prescriptively, you're under 40. And if you go down the energy model, it's exactly the same. So anybody do residential here? A few. So if you get into high-rise condos or mixed use, actually mixed use is a big thing. You get into the mixed use side, you may go down the energy model, and the energy model gets you more ability to dance around and interchange a weaker envelope with other things. When you go down the prescriptive path, I can exclude all the lighting in dwelling units. When I go down the energy model path, I have to allow for 5 watts a square meter for all the dwelling units. So I may have got a better method, but now I have different restrictions to comply with. On office product, on schools, universities, exactly the same. So we have to look at designing differently, which means we place glass where glass is necessary. I love daylight. Mechanical folks want a bunker, right? So between the two, we find a compromise, and then architecturally, we want lots of glass. So we want daylight, but we put daylight where daylight can work, where the glass can make it work. And then we go with a double, triple glaze system. We go with frit on it to deal with the glare on the outside. The blind solution on the exterior of a building doesn't work. So we look at things very, very differently that can work passively, not active components. And doing all of that is now required for building permit. So you have to select your finishes. And yes, if we're working with you on a project and we're doing schematic design, the very first question we will ask, other than which path are we going down and are we doing LEED and so on, what's your color palette? And we usually get this, what? We want to know the color palette. I don't need to know whether it's mauve or pink. I need to know whether it's 40% reflective as an average within the room, 60%, or if it's 10. Because if it's 10, we have a big problem. We may not meet the lighting power density that we need. So we talk about colors up front, and that needs to be sorted before we go for building permit. Now, if you decide to change all of it after building permit, we now have to change our design to accommodate the lighting level needed to comply with AES and WorkSafe, and at the same time meet the energy targets. Very, very important to communicate some of this up front. So why I harp on this? It's actually done wonders, and we go for permit on all of our projects. Our projects are 99% designed. The only thing not included in our permit set, possibly, is our detailed spec or circuiting of receptacles. Other than that, everything is in. We switch receptacles, we deal with lighting, we deal with the controls, we put in dimming, and so on. And then at occupancy, we ask for commissioning. We want a document that states the lighting and lighting controls are properly commissioned, because nobody would buy a $100,000 BMW and expect the windows not to work walking out of the dealership, so we shouldn't expect the same thing of a $100 million tower that we're working on. So that's what we do on all our projects, and it's very, very successful, whether it's West Coast down south or the next of us. Here's an interesting suggestion. We do this on all our projects. Doesn't matter where we do our project, any part of the world. We put energy statements on them. So we design a drawing, we design a set of drawings. Before it goes in for permits, right on the cover, we put what's called an energy statement. We include what code we're designing to, what standard we're designing to, when the permits are going in, because when you're doing an alteration in future on, you want to know what the initial code was that you designed to. So the interpretation in Alberta, I'm designing a building today, I get occupancy tomorrow. 7 years from now, I want to do an alteration. The alteration will not be to NECB 2011. The alteration will be to NECB 2015 or whatever's enforceable 7 years from now. But I need to know what was installed as a base building condition. So we put energy statements on the cover page of all of our documents, and we submit that for permit. Everything's right there, and it talks about whether we're going prescriptive or performance and which code we're working with. These are some sample forms from, I'm talking about BC here as well, and I'll skip through some of this because we've got some examples here for Edmonton and Alberta. One of the ones I put this up for, one of the ones I wanted to point out to was, if you have a look, occupancy permit stage. So right on the checklist that we need to submit to the city, if you're doing a project to the west of us, the very first box, I have built what I have designed, check that off. And we try to do that, and right now we're doing about 7 to 8 out of 10 projects are we checking off that box. The next one is I have made changes, and the following sections in the code are where the changes are, and the following drawings is where you'll find them. And this is now coming into the schedules and the compliance forms into Edmonton as well. We have them in Calgary already. So back to Alberta. Province of Alberta, we've got 2014 ABC, we've got NECB 2011, and we've got compliance forms. I've talked a lot about these compliance forms, and nobody really had worked with them, and nobody seems to have some familiarity with this. So where do we find these compliance forms, and where do I get a copy of them? We end at 10:30. Everyone's going to run out of here, get to their office by 11. We're going to log onto our machines. We're going to go to NRC's websites. We're so excited about NECB, and we're going to download the books. But before you do, don't download just the NECB. Download the NECB user guide. So if you're working in the city of Edmonton, Edmonton has forms for you. Calgary has forms for you. Other jurisdictions may or may not have forms for you. So where they do not have forms, we introduce our own forms. So if you buy the user guide, at the back end of the user guide are forms. These forms are not editable, so we cannot edit them. Only the AHJ can edit them. So Manitoba has edited them for their use. Calgary is done for their use. BC is done for their use. We're working in a jurisdiction that doesn't have anything specific to that jurisdiction. Use these forms. So at the very top, it's building envelope compliance. The next section is lighting, which is part 4. The next section is HVAC, part 5. And then we've got service water heating. And then the very last one, electrical motors. And the very last one after the OR is energy modeling. So all we do is we check off the right boxes when we submit the forms. Now, if an authority having jurisdiction does not need forms in the province of Alberta, do I need to submit the forms, or my stamp drawings are sufficient? Yes or no? You need the forms. Okay. Anybody else? We've got professionals in the room. We're signing a Schedule B. We're signing a Schedule C. If you're an architect, you're signing a Schedule A. We are signing documents that say we are complying with the codes that are enforced in the province we are working in and in the authority against which we're pulling a permit. When we make that statement, we are saying we're complying with all the codes, which means we, as professional engineers, when we comply with APEGA, we make sure we do what's called a peer review. Somebody's checked the work that I've done to make sure we haven't had a mistake. And we have a peer review process, which is OQM, and we make sure we comply with it. We have to do that regardless. So if a AHJ does not need the forms, you're going to fill out the forms to make sure you have complied with the code, because when your project gets audited, you can pull out the forms and somebody can review it to make sure, yes, I have done my due diligence. And that's part of the requirement for us as professionals. So whether AHJ needs it or not, you should be doing them. Compliance paths, prescriptive or performance. So the one on the left is prescriptive or trade-off. The one on the right is a performance-based path. Very simple way to understand the two. The one on the left is textbook case scenario. Follow the book, do what it says. The one on the right is performance, and I can do a demonstration that even though I've got an envelope that's not very strong, or I've got a lot more glazing than necessary, mechanical and electrical systems that are put in offset that. But you have to demonstrate that. On the left, I can do a trade-off, and I can do prescriptive. Trade-off is I can trade from one area to another area. So if one area is weak, I can trade it with another area, and the overall energy balance of the project is compliant. That's what trade-off is after. Lighting specific. So when you drill down into NECB, if you get into the appendix, there's a drill down specific for every discipline. The one specific to lighting, prescriptive on the left, performance on the right. And then prescriptive on the left, we've got what's called the building area method, and we've got the space by space method. So building area method is one complete building. So if I take a typical mixed-use office tower, I've got metric, 10,000 square meters. So 10,000 square meter building, and in the building I've got 3,000 square meters, or I've got 3,000 square meters of retail on the lower level. I've got retail on level 1 or 2, and then I've got maybe an office product, and then everything else above that is office as well. So if they're broken up into two different spaces where they're majority spaces, you have to do a space by space. When it is 95% one type of building and then one CRU in the corner, you can apply the majority to the entire building. We typically do space by space method, always. Schematic design, we look at the building area, 10,000 square meters, office product, watts per square meter. I'm allowed for 1 watt a square foot or 10 watts a square meter. I do the math. I've got 100 kilowatts. I'm okay. It works. When we get into design and detail design, we actually work further and get into space by space. Why? Because when I do a room like this, I'll need 4 sensors. 2 here for occupancy and 2 here for daylighting, because I've got daylighting zone there. Or I spend a little money and get fixtures with integral sensors, and then I can do both of them at the same time. If I'm in a bathroom, I need different type of sensors. I just need on-off, but I need ultrasonic. Because if you're in a stall, you want to be able to make sure the lights don't go out on you. Stairwells, same thing. We're doing lighting control. Parking garage, we've got to turn off lights as well. So they're different by different space, so we use space by space method. And it also helps the mechanical guys because they take the space load and put it into their energy model. It helps the architects when you're doing a Revit deployment as well. This is a form. I'll qualify it. This is only for lighting. This is only part 4 of all the disciplines. This is page 1 of 5 pages. The very first one you're looking at, trade-off path for electrical, and on the right-hand side, you'll see a whole bunch of red boxes, and I'll talk about what that means. 2, 3, 4, 5. That's just lighting, and we've got the same for all the other disciplines as well. And whether the AHJ needs it or not, we do it. We've got to make sure we qualify. Here's an example of one where we've got the performance method, and you can look right at the very top. There's a check off on compliant, and you see the box on the right is green. Below that, it's asking for a fuel source. We pick natural gas. It turns green. So when I fill in all the boxes and I fill in all the information that's required, it goes from red to green. Once it's green, I'm compliant. I submit that to the AHJ. And if they don't want it, I keep it as my record anyways to make sure if I get audited, everything has been done per compliance with my rules for APEGA. The earlier slides that I'd put up, 5 pages for part 4, and then the other 3 were for the energy model. We've got to do the same with the envelope and hot water and other disciplines as well. And then we bundle all of that and we submit that to the AHJ. If we're not doing that and we're doing an energy model, we hit the print on the energy model with the parameters that they want to review, and we submit that to the AHJ. And then on completion, the AHJ will ask for verifying the energy model or prescriptive path. Prescriptive path is easy. Walk through the space, everything is built exactly where they've said they'd put it in. Performance, you need to do what's called a blow test. Pressurize the building and see if there's any leaks. And then you demonstrate that I've met the number that I said I would meet when I submitted my design package. Projects are getting rejected if they're not compliant with that because you're simply not going to get a permit to occupy. And provisional we've talked about already. So for our friends on the Part 9 path, this is the table you want to familiarize yourself with, 936 subsection 1.3 within the appendix. 9.36, when we created it, there's still some gaps. So 9.36 applies to many, many types of buildings, and if you see the 3 columns, the first one is ABC prescriptive, then it's performance, and then it's NECB. So if I've got a Group D building under 300 square meters, I can do prescriptive performance, I can do what I want. If I've got a Group D building above 300 but under 600 square meters, the only option I have is to do NECB. It's a Part 9 building going for Part 9 compliance with 9.36, but because it falls in the gray zone of larger than 300, less than 600, I'm doing NECB. And lighting design for any Part 9 building, if you read the lighting section, it says comply with NECB. you're doing NECB for all of lighting anyways. So this table is very, very important to review. F1 type occupancy is excluded completely from 9.36, so you have to go right to NECB 2011. So have a look at that and see how it works for your projects. Back to Edmonton, Edmonton specific. We've talked about the dates already, so I'm not going to get into that in too much detail. Stan Data, when they published this document, how many people got this document, placed it on a file somewhere, and then never looked at it? Many culprits. I'm surprised you put your hand up. Many, many of us did it, right? Stan Data, we'll look at it. So we looked at it, and all Stan Data said, well, actually, some people did even better. There's 4 parts to it. Everybody skipped to the, oh, there's a 6-month extension. Okay, no problem. Nobody read the other parts. Well, the other parts are actually more important than the damn extension. So the other parts talk about, this one is very, very important. Safety codes officer has the authority to shut a project down if it's not compliant with NECB or 936. They can't just come in and shut it down because you've got the wrong door, or it swings the wrong way, or handrails. They can actually shut it down because you haven't complied with energy. We have a case on a project 4 years ago where a building inspector walked in at the very end. Where's the occupancy sensor? And we were brought in to do the audit. So that wasn't our design. We were reviewing it on behalf of the police department. And so where's the sensor? Well, it's missing. Well, it's required here. Where is it on the drawings? Well, I don't know. You gave us a permit without it. Well, that's not my problem. I'm here to do the final review. You don't have a sensor, you're not getting occupancy. They needed occupancy the next day because they were getting out of their space and into their new space, and the new space wasn't ready. So they lived in an ACO trailer for the next 6 months, and the lawsuit is coming on completion shortly, but it's been about 3.5 years in the making. So just because you got a permit and the AHJ said, or didn't review that level of detail, they have the authority to stop it at the other end. So we take the responsibility of making sure we comply with this. Very important bulletin. The next one, interpretation, and this is saying basically NECB and ABC are enforced, and they both have to be, you have to demonstrate compliance with both of them. 9.36 in scope, I've already talked about it, and if the base building was constructed to NECB 2011, all future tenant improvement and all future alteration must comply with it. If it's an older product that is not built to NECB, you don't have to do it. That's the very, very basic interpretation. So all your TIs and alterations in an older product, don't have to do it. Anything in a newer product, have to do it. Extension, expansion, vertical, horizontal, or mezzanine additions, you have to do it. City of Edmonton compliance forms, where do I find it? They have them. It's actually a very, very nice form. And they've identified the portions around energy that you have to refer to. It's in red. Everything else is in black. So if you have a look at the form at the very top, under A is project information. Right below that, the very first section, comply with 936, comply with 2011, or don't have to comply, not applicable. Next slide, further detail. How are you complying with it? Give us some more project information. Exactly the same detail that we extracted when we did the forms years ago in another province. Summary form on NECB. Exact same form again. So when I'm submitting for a permit, I indicate all the engineers, all the disciplines, all the design information that I am complying with, including fenestration level, amount of glazing, amount of penetrations, amount of opening. I put that right on the summary form. And if the summary form doesn't look good, you're not getting permit. So make sure the summary form looks good and the rest of the forms look good. And I'd encourage every professional in this room, if you're submitting for permits and there is a form, please make sure every box has something in it. Not applicable is an acceptable answer. Do not leave it blank because you may not get permits or you may go back to the start of the line. They've actually got a detailed explanation on how to use the form within the online process at the City of Edmonton as well. This one is a trade-off path calculation tool. So there's an online calculator that allows you to calculate whether you're complying with it or not. Very, very powerful tool. We've got this and we've got our own in-house creation of something similar that we work with. And then the statement of compliance and summary form, and you're signing on the dotted line right up top. And you're also demonstrating whether you're checking 1 or 2 and coordinating professional. And I had a question last time. Does the coordinating professional take all responsibility, or is it the authority having jurisdiction? The answer is the coordinating professional takes all the responsibility. So if you're signing off on somebody's energy model and you're the architect or the engineer and you're taking responsibility for it, it is you, not the city and not the province, and you can't default it on them. Part 8 compliance form, so this is the energy modeling. So if you're doing an energy model compliance, you're demonstrating compliance with the form. Reference case in the building, proposed, reference proposed. How have you done better than the reference case building? That's really all it is. And then if you're going down the carbon play or if you're going down the lead play, you want to do 20, 30, 40% better. And then you're doing better than base. So you've got to demonstrate that as well. So industry trends, some of the more fun stuff. LEED. LEED used to be version 2009. It's now version 4. One of the benefits of version 4 in Edmonton or in Alberta is we can apply NECB as a compliance method within version 4, previously not allowed. So NECB can be applied, whether you do an NECB or not. Anybody know the main difference between LEED version 4 and version 2009? Materials. Okay, yeah, that's one difference. That's not what I was going for. The main focus for LEED was really about energy. So let's reduce energy and let's reduce the cost on it. LEED version 4 is a play on carbon. Let's reduce carbon. Saving energy may save you some carbon. Saving carbon is what the world's about between now and 2030 for the first challenge. And then the feds have put out a second challenge for 2050 where we're going to be greenhouse gas free and off the grid. We'll talk about some of that as well. The other thing that's new in here is a bug rating system for lighting. So lighting has gone from fluorescent lamps, HID lamps, and metal halide, and we've gone into LED sources. What have we done? We've taken the same can and the same box and we popped a new source instead of an old one. An LED source is like this pointer. It's a ballpoint pen. And a fluorescent source is like a big fat marker. And try highlighting a page with a ballpoint pen. Not possible. So we have to change the way we design the fixture and put optical reflectors in there to make sure we get the light out properly. When done incorrectly, you have a problem that's known as glare. Anybody walk through a parkade that's just been retrofitted to LED fixtures, and as soon as you get within the 45-degree of the fixture, you start getting blind. It's that glare bomb that comes into your face. So there's a new bug rating system. Backlight, uplight, glare. If it's a flood or a shoebox or a high bay or any type of fixture that should have that rating on it, we don't spec a product that doesn't have a bug rating because it's going to be a glare bomb. So work with products that are displaying the testing that they've gone through. The new language for the industry going forward, I know LEED or NECB is still fairly new in Edmonton, but we've been doing it for decades here. Energy use intensity. What's your EU? That's going to be the model. You go into Europe, I walk into Germany, we talk to a lot of customers there. We've got an EU of this and that and the other thing, and that's what we talk about. Data centers, we do a lot of EU talk. So EU is your overall energy use intensity, kilowatt hours per meter square per year. Greenhouse gas, neighborhood renewable energy system, and then thermal demand, and some of our mechanical folks might be very familiar with it. Alberta Climate Leadership Plan, very, very, very aggressive, very doable, but it means we're going from 0 to 10, and we're just running. There's no time to look back or do this twice. We're just going to run. Coal-fired power plants, we're getting off of them by 2030, and 30% renewables by 2030 as well. Very, very aggressive target in Alberta. When I say it's very aggressive, it looks very, very painful to do. So I'll bring up another reference case, province next door. City of Vancouver and the province of BC. We've got a zero emissions building plan that was just published about 6 months ago. We've got to go 90% greenhouse gas, reduce our greenhouse gas emissions by 90% by 2025. So if you think what we're doing in Alberta is a bit, are you nuts? It's even nuttier in other provinces. Zero greenhouse gases by 2030. And for all the architects in this room, we're finally, actually, possibly, maybe going to hit one of our targets that we set out architecturally, and we're going to hit the 2030 challenge. This is the 2030 challenge that every architect through their institution has worked to create, and I commend you guys for doing it. We're actually going to be able to do it. First time. The last one, 100% renewable by 2050, that's across the nation. Federal government, of course. Now the federal government, why do I care? If they're a tenant within your building, they will not occupy a building unless your building has renewables on it. We have a standing offer with Public Works, and we're now engaged to go and look at installing photovoltaics on top of all their buildings, whether they're a landlord or whether they're a tenant. They have to get 30% of their power from clean, renewable sources, and that's a big push that they're making. 100% by 2025 as well. Here's a cool little chart that I put up for folks that are able to read some of it. So if you have a look at the column on the very left, and the very first one that talks about typical outcomes of doing a project today. This is in BC, by the way, not in Alberta, part of the zero emissions plan as well. So today, my greenhouse gas targets would be about a 9. And 2016 limits are about a 9. In 5 years, we've got to cut it by down to a third. So if I'm starting a project today, because it takes years to get a permit, years to do design, and years to do construction, I'm going to be at 2020 or 2025 limits. By 2025, zero greenhouse gas emissions. And that's going to be measured. The feds have also put something out which every province is going to look at adopting differently, where we have to display our energy consumption by building and all provincial buildings. So we'll have a meter up front and a display that's going to demonstrate how much energy we're using, how much water is being used, and how much waste is coming in and out. And that is going to get measured across their inventory across the nation. So, what's new in NECB? On the power side, some basic requirements around making transformers very, very efficient. And the big one is on services that are 250 kVA or larger. So on a 600 volt system, a 250 kVA, or another way to look at it, on a smaller building, about 25,000 square feet or larger, 20,000 square feet or larger, this would apply. We have to provide the ability to meter each portion of the distribution separately. So anything larger than 250, we have to provide infrastructure so that the tenant or the client can go and do metering later on. That's what this talks about, and it needs to be done in every building that meets that requirement. I put this up. This is a definition of parking and a garage, because we get a lot of pushback, and then when we point out how it's laid out in the code, then it's a little bit of pain and suffering. Part 1412, Division A, define terms. Any space within a building envelope, conditioned or unconditioned. And this is the definition under NECB. Sheltered space, storage garage, parking garage, does have to comply. So if I've got an outdoor parkade, 4 columns on the exterior, drive aisle in the middle, and I've got a parking structure, I comply with the definition of NECB, which means I must comply with the requirements of it, which means I have to turn the lights off. We're turning off all the lights in the parkade when no one's using the parkade. That is code and mandatory. So we have to look at designing buildings a little bit differently. Lighting power density I talked about many, many slides ago. Lighting power density is really the total amount of energy that I'm consuming in watts on a project. I have a maximum number. My 10,000 square meter building in Alberta that I'm designing for an office tower for a tenant or for a landlord that's going to occupy, I've got 10 watts a square meter, 9.7, roughly 10 watts a square meter, and that gets me about 100 kilowatts. I've got 100 kilowatts. I can use it all in the atrium and the bathrooms and make everything look good, and then in the offices, if I run out of kilowatts, I'm going to hand out tea lights from IKEA because there's no more kilowatts available. You cannot add more than that number, which means we have to design it differently. I talked about the finishes already. We have to have control systems. We put light where lighting is required. The design in this room is great. This room will never comply with NECB. Way too many lights in here. The other item, or the other example, I can put the lights in and put a dimmer on it and restrict it. Not compliant. It's the amount of energy you can potentially consume. So the way we have to do design has to change. And yes, it's very doable. We're doing a 40-story tower in Calgary. We're doing other mixed-use projects. We're doing some institutional work at universities as well. Very, very easy to comply. But we have to talk at schematic design stage, not at the end of the job. Watt allowances I've already talked about. And the targets here are very, very achievable. LED product helps you get there, and it doesn't mean you have to convert all to LED. And we've done a cost comparison recently for K-12 school, and the fluorescent and the LED lighting package for this 8,000 square meter facility was exactly the same cost. The difference, the LED package had built-in controls because all the light fixtures have a built-in sensor. So controls are already in. So it's automatically cheaper. And then when you go in the O&M cost, the lamp and ballast re-lamping and re-replacement, because we're turning things on and off on the fluorescent model, was 6 to 10-fold of the LED. So you put that in for 30 years, you may or may not be changing some of that product. Now, of course, we have to design a facility, so we need exceptions. So there's some exceptions. There's retail. You get exceptions on retail spaces. You get exceptions for growth. If you want to do some plant growth, some specific type of plants, you can get exceptions for that. So there's ways to comply with it. You walk into a Subway, you walk into a Tim Hortons, you walk into a retail environment. There's things that we can exclude out of the overall lighting power density if we design it properly, which means when you're procuring equipment, talk to us. We'll let you know whether you should buy it integral or not and how to do the controls with it to make sure it complies or get some exclusions. On lighting control, the best way to think about it, if there is a room that is not occupied, you're turning off the lights. Everybody here is not at home. And I'm pretty sure if nobody else is occupying your home, the lights are off. We have no problem with that, but in the work scenario, we have a challenge because there's so many users. That's why controls have to be done differently. And you can't just put a master switch in a corner and call it compliant. That's non-compliant according to NECB. We have manual control options. We have automatic control options. The control by the circuit breaker and the back panel that turns off everything on and off, that's not acceptable. I'm not going to get into too much detail on here. It's very prescriptive. Give us a call. We can go through it with you as well. Every enclosed space needs a lighting control. It can be automatic or manual. Temporary lodging, we do a lot of temporary lodging, so we do temporary lodging for construction either up north or here. You must comply because hotel and motel and temporary accommodations, we have to have controls for bathrooms and other requirements within the space. So we have to look at doing this on all types of spaces. Now, whether it's a temporary lodging that complies with ABC or NECB combined, or NECB is excluded because the trailer moves from site to site to site, you have to talk to AHJ to get their interpretation on it. Additional control, so furniture lighting and task lighting. We have to have some control. We have to have control in guest rooms and rental rooms or suites. So if I've got a hospital, in the hospital I'm a patient, I'm within the room, it's a suite. I do not have to do additional controls there because there's no monetary exchange. But anytime I have what's classified as a suite and there's monetary exchange, you have to treat it as a separate unit and do separate controls. So lodging without a kitchen, if I don't have a kitchen, it's not a dwelling unit, it still qualifies as a suite by definition of NECB. Look at the back, it's clearly spelled out. If I've got an office space and I'm breaking it up partitions, I've got separate suites where you exchange hand for some coin, you have to comply with it. Additional requirements, you need separate controls for many, many things, and they're listed out there as well, and in the book as well. Daylight control. Traditionally, the one thing that gets value engineered on every project is the lighting controls. We did Edmonton International, and Kevin and I went through that concept in 07, 08, 09, and we had controls in there everywhere. You walk through Edmonton International to fly out, whether it's departure gate, domestic or international, all that's VE'd or it's not turned on or it's not working properly. It's the first thing that gets value engineered on every project. Cannot do that anymore. It's actually required by code. Top lighting and side lighting. So if I've got side lighting, like this room has side lighting, I need to have dimming so I can turn off the artificial illumination when the natural illumination exceeds that. For everybody in this room, if we were to run the seminar in a different space, where would you want the space to be? On a beach. Yeah? Number 2 is your home. The 2 most comfortable spaces on the planet, and we'll do whatever it takes to be comfortable there. Do we have the lights on, glaring, when it's nice outside? No, we adjust and we accommodate. That's what we need to start doing in our work environment. So behavioral changes have to come into play, and that's a whole different seminar. Automatic shutoff, I've talked about it for parking garages. So parking garages, bus shelters, retail outlets, we need automatic shutoff for lighting. So this type of approach to lighting design for our parking lot is no longer acceptable because we have a limitation on the lighting that needs to be used. So we paint all of our parkades and we get higher reflectivity, so we comply with CPTED. CPTED is very, very big. If you want to turn the lights off, we can't have central sensors that turn on mass groups of lighting because somebody could be hiding in a corner. So we put integral fixtures, we put sensors into each, and we turn them on and off by zones. It's not much more money. It's about the same cost as a traditional control scheme. And we achieve the requirements of saving energy and complying with NECB as well. Exterior lighting, you have to turn lights off, photocell, daylight, whichever method you use. This is a beautifully lit building in the middle of the night that we all like to go and take pictures of. This is what we are going towards. If it's not occupied, it's at night, we have to be dark sky compliant. Dark sky compliance is now a big thing, and it's enforced about 6 months ago. Dark sky compliance means we should not interrupt the enjoyment of the space for humans and for others. Others are birds and any other flying object. We have to be dark sky compliant. The other thing that's new is the lighting color temperature on all exterior spaces is about 3,000 Kelvin. 3,000 Kelvin is this yellowy glow. Traditionally, all exterior spaces is 4,000, the blue and the white bright light. That's not dark sky compliant. So this is what we need to change. Commissioning. One of my most favorite subjects and one of the most controversial subjects. Everybody wants commissioning to be done. It doesn't always get done. Please, the one thing you do in your project schedules, you change the schedule, move construction, add a month in, add 2 months in, take it out of design, take it out of the broker doing the deal, take it out of the owner taking time to make decisions. You add commissioning in. It is the best thing that you could do for any project, and you will actually comply with all the requirements of the code, and it is mandatory. NECB says, I have to install this. When I issue a schedule, you're saying it has been installed and it works. How do you verify that it actually works? Commissioning. So, after all this rant around why bother doing this, who really cares and why should we have to do this other than I have to get a building permit? Some of the things we have to start looking at very differently, and I've spoke about it already. You've got to look at lighter finishes. So we can do dark in certain areas, but we need generally lighter finishes. Why? Because if we've got a higher than 33% fenestration ratio to solid wall, I want to be able to offset that by mechanical and electrical systems. Mechanical will rely heavily on electrical. In order for me to cut my lighting down, I need higher reflectivity. Make sense? The brighter the space, the brighter it feels, the brighter the light is within the space. Furniture we have to look at differently. Parking structures have to get painted. And using a certain product and a certain style of lighting everywhere doesn't work. We might have to look at different concepts for different areas. If the corridor is wider, we can look at a certain type. If it's a narrow corridor, a cove lighting may work. Cove lighting, for example, is the heaviest consumer of lighting power density because it's very, very inefficient. It's tucked in the corner and it's shoving light out. Electrical budgets, I've already talked about it. We cannot value engineer controls. Do not value engineer controls. It's going to come out of something else. You need controls. Imagine buying a car and you're going to turn the window down like that. You're going to buy a car today and do this, to turn the window up and down. Not possible. We got to have these systems in, and you're just not going to get permits in occupancy. This is one of my favorite slides as well. If you have a look at it, on the top right corner is a building. It's a building for Ritchie Brothers. They commissioned us in 2005, and we designed their head office in Burnaby, out by the river. The building was designed in 2005 and 6. They got occupancy in 2008. That building today complies with NECB 2011 or ASHRAE 2016. It has controls, lights turn on and off as you go through the space, the lighting is at the proper height. Look at the wood in the space, I don't know if you could see it well in the back. The color of the wood, the texture of the wood, the color of the concrete, where we wanted glossy and reflective concrete, where we wanted flat concrete. We did that level of detail in schematic and concept design so that at the end, we got the lighting power density at that time to 8 watts a square meter. Code was 14. Code today is, office I showed you earlier, 9.7. So very, very, very doable. Budget was 4.6 million. We concluded at 4.635. About a decade ago. The one on the bottom left is a shopping store. Nordstrom's, The Bay, Sears, any fancy store. You're never going to design that. Lighting for a department store or a retail establishment used to have a budget of 31 watts a square meter. Sorry, I'm jumping between imperial and metric. 31 watts a square meter. Today, the lighting density for retail is 15, half. So when I design Starbucks, Microsoft, Lululemon, Sony, when I'm doing all their studios, we get this plan that comes from New York or LA. This is our corporate branding, go roll it out. And usually that's troublemaker in the meetings. Why we can't do this? Because you're not going to get a building permit. This is not compliant with NECB or ASHRAE. Go rebrand. Anybody tell a CEO of a company, go rebrand? It's actually a very fun meeting. You're just about getting shot. And then when you explain the logic and the process, and the option is pull out of this region or rebrand. And they all rebrand. That's the only way you can comply. How do you go from 31 watts a square meter to 15 by just taking half the lights out? It's not possible. Currently on alternate compliance, I put some of this up because we always get asked, okay, well, if this is one of the models to go down, what else is out there? There's nothing in Alberta. In BC, there's ASHRAE, there's BOMA Best. In Ontario, about the same as well. There's ASHRAE and NECB. In Alberta, we've adopted NECB. NECB, in my opinion, from an on-wall point of view, is the better code. It is much better for the environment we're in, especially in Edmonton, Fort McMurray, and any more north that you go. When you get down to Calgary, you're kind of borderline at 4,000 heating degree days. But there is no other option. This is what we are doing going forward. So to conclude, project startup meeting, you get the design team together, define the project goals, which we all do very well, and the owner pulls out their statement of requirements, the SOR, the PDR, whatever document. That's the Bible for how you do design for their facility. Which code is applicable? If I'm on federal land, is it NBC? Is it ABC? What am I complying with? If it's a trade permit, do I have to go down the NECB route? Am I doing something different? What do I have to comply with? You may already know the answer, but make sure the entire team is on the same page. And the entire team has to do the same code and the same application. We cannot pick and choose energy model for one and prescriptive for another. And no, it's just one method for everybody. Lead we talked about. Decide as a team how we're going to pursue this and how we're going to achieve the targets. Calculate all the wattage and the watt allowances and work with mechanical. And then do what we're supposed to do but don't really always get to do. Have some fun while you're doing this. And that's it. Any questions? We've got till 10:30. Yes, sir.
I was just wondering about the dark sky requirements. In Edmonton here, you see a lot of those big LED screens. And I was just in Sedona in Arizona, and it's against the law to have lights on at night.
Correct.
I'm just wondering how City of Edmonton is going to deal with that.
We're going to help them do it.
Take them down.
This is so new, and it's been a year. We launched our Calgary office on the implementation date. So November 1, 2015 was Calgary opening. Edmonton just happened to line up. We're opening it this morning. This has been in practice in the other province for about 25 years. We're just getting our act together. What's going to accelerate this, in my strong opinion, is when we start talking carbon. You cannot do a project today if you don't talk about carbon. And if you're not talking carbon, your project's not going to get done properly. Once that acceleration starts, all of these will get done automatically. Any existing product, they don't have to do anything to, but any retrofits, any add, mod, deletes, this will have to be complying with dark sky and exterior and shutoffs and so on, in addition to safety and security. I forgot to mention safety and security. There's an exclusion in the code that says if your space is required for 24/7 operation or for the safety of patrons, you do not need to turn the lights off. So a consultant's office that works 24 hours a day to meet our deadlines, it does not comply with that definition. Nor does an outpatient hospital, because outpatient means doctors go home at 5 o'clock. 24/7 is RCMP, maybe prisons, even then we're not sure, and definitely the OR department and the emergency within a hospital. Otherwise, no. So as we move forward and deploy projects, we will have to do it. In another city in Alberta, in Red Deer, we're looking at working with them to go from changing because everybody went down the path of 4,000 Kelvin, and dark sky compliant is now 3,000 Kelvin and softer light and so on. So we're working with them and changing their metrics, but it takes time. The private sector is what's going to accelerate this, and I'm glad to see such an audience. And there's 4 or 5 other seminars on the same topic, and so we look forward to it. Any other questions? No?
I have one.
Yes?
What are the impacts on the costs of the projects to start in result of these? Any information? And the second one, operating costs. Changing to the white carpet, just using it as a placeholder, is going to have an impact on the maintenance cost. How are the users, operators, and the owners to conduct themselves in this case? And how do you convince, how do you present?
Yeah. So the question, there's 2 questions. First question is, how does CapEx get affected? What's the total initial cost to a project and capital cost, and what are the changes? Second is, operationally, we have to do things differently. How are the facility managers coming on board with this? There's a cost to that. You want to speak to what's happening today or experiences from other jurisdictions?
I'm asking, how would you answer it?
So the cost premium for NECB, if you go and blindly apply it without looking at trade-offs differently, there is a cost premium. Let's not kid ourselves. You're looking at doing things differently. However, there are trade-offs. If you do your fenestration properly, if you design glass properly, you go into a triple glaze model, go with frit, remove some of the other things, and put glass where it's needed, you have some savings there. If you design the lighting properly and you integrate the sensors, the same sensors can be used to detect HVAC and carbon and CO2 within the room, you can have some savings. Overall, to the industry, initially we've seen about 5 to 10% increase because of introductions of some of this. In BC, not so much on projects in southern BC, in northern BC. Northern BC, because we have to deal with envelope. Southern BC, you kind of can still do a 70-80% all-glass project. Here, no. So it's the envelope increase in beefing up that's going to see some changes. The latter question around, I'm going to go from darker finishes to lighter finishes. So lighter finishes help the cleaning department. They help the janitorial, the sanitation, because you can actually see and keep space better. And it's actually a requirement under WorkSafe to keep brighter spaces. However, now the maintenance people may see more wear and tear, so now you have to replace the product more often. That gets rolled into how they manage the facility. And business has to change. My slide at the beginning, or halfway through the presentation, that talked about we have to look at doing permits differently, we have to look at doing occupancy differently, and at day 1 I'm going to talk about commissioning and work with the general contractor and the CM in changing their construction schedule. If I don't do that, I'm in trouble. So collectively, if we work, it should not be that drastic of an impact, but it's a huge learning curve. And the learning curve here is we're going from 0, and we have to be at 10 5 months ago. So there are some challenges, absolutely. Yes?
You mentioned making decisions early enough about finishes and that affects the energy model or the energy calculation. When you're doing core and shell work where you're not really sure who's going to be going in there, what kind of considerations do you need to think about up front to make it easier?
So the question is, if I'm designing a project where the finishes are to be put in, it's easy. But when I've got a project where I'm doing core and shell, where there's no finishes because I'm designing a shell product, how do I design that project? You have to put in, well, let me rephrase that. Our experience in achieving that successfully has been to put in restrictions on the TI manual. So the Schedule Cs, that tenants come in and move into that facility, we restrict the amount of energy they're allowed to consume on the lighting. We restrict the amount of energy they're allowed to consume on the receptacles, and the same with HVAC. This is the airflow you're going to get in the room. These are the CFM's maximum minimums. And we keep that to make sure they do not exceed the model that we have used to design our proposed project. So let's take your shell building. Shell building, the easiest example is an office building. So an office building I'm doing, it's a shell space. I don't know who's going to go in. I still have to design the envelope up front. That's not going to get designed later. The parameters to be used under the rest of the systems, I either do prescriptively or I do performance-based. If I do prescriptively, I'm going to have 3 feet of glass all the way around, and no broker is going to want that, so we go down the performance path. Then the electrical and mechanical folks put in some qualified assumptions around this is what we typically can expect. and then the energy model comes back with the risks, and based on whatever you conclude on the energy model, we have then taken those requirements, we've put them in the Schedule C, and the landlord and the broker go and market that with those restrictions. That is how we have been able to get past this very, very successfully. That's the way to look at that. Yes, sir.
What's the biggest difference between NECB and 936?
NECB 2011 versus 9.36 is the application of building type. So NECB is for larger buildings, and the 936.
I realize that.
Yeah.
I'm saying, what are the actual core differences? Because you had made reference to the fact that parts of Part 9, you still have to meet NECB. So my general thought is, well, just meet NECB. So I'm then wondering, well, what is the difference? What would be an advantage to meeting 936 versus NECB?
Correct. So the question is, what is the main difference between 2011 and 936, when 936, as I clearly pointed out earlier, is not applicable to all project types. So 9.36 is created to address small buildings. Small buildings that are really small buildings, technically small buildings, 3,000 square feet and under, you can do it. When it gets past the 3,000 square meter to 6,000 square meter, or 600 square meters, sorry, the qualifications that they've put in prescriptively, you cannot achieve those targets. So the only way to do it is go down the qualifications that they've put in and metrics that they've put in the NECB. So you're really taking that Part 9 building that falls between the 300 and 600 square meter zone, and you're designing it like an NECB building because it was actually designed to go down this path and not the Part 9 path. And that's been clearly identified within their scope.
I realize that. What I'm asking is, what is the difference?
Which discipline?
Like, technically, like, is there an envelope difference, for instance?
Yeah, so lighting-wise, there's none. On the envelope side, there's a difference on your exterior, on the insulation values. And then mechanical systems and air ventilation, there are specific differences between the two.
Is it fair to say that 936, everything else being equal, would be cheaper to meet from a capital cost point of view?
What type of building?
Well, it's a Part 9, say you're building a Part 9 office.
So Group D occupancy.
Yeah.
Group D occupancy, Part 9 would be more restrictive than NECB. Group D. Group B, F3, they're different. So depending on the type of occupancy of the building, you have to look at it differently because you actually do not design for a lot of glass in a Group B or an F2, whereas a lot of glass is necessary in a Group D. So depending on the building type and the size, and the gray zone is 300 to 600, you're absolutely right, then it's either better or worse for you, either envelope-wise or mechanical-wise. And that's a true comparison that you have to do. And when you pull up the user guide for NECB, it actually steps or walks you through the main differences and how they've changed it and which one you can use to apply to your project better.
Okay.
Any other? Yes?
Does the dark sky compliance apply to exterior site lighting, whether for security or building decoration?
You said two words together. You said security and building decoration. They're not interchangeable. So building decoration is lighting that's on a building to illuminate for no other purpose than to illuminate the building or to beautify the project. It doesn't serve any other purpose. That type of lighting we have to address. We have to turn it off. Any lighting that's required outside for safety purposes, for patrons and so on, we can keep it on, but we have to demonstrate that it's required for safety. If not, you have to turn it off. So one of the best examples I'll give you is a fire hall. So if you're doing a fire hall technically is 24/7. However, the fire hall is not utilized 24/7. When there's no fire, the firemen are actually asleep in the middle of the night. So we put in lighting to achieve that intent by lower levels of illumination that then can ramp up. So there's different ways to achieve it, but dark sky compliance is required for all exterior spaces. If it's just to decorate the building, you don't need that lighting. You have to turn that off. There was a hand here earlier, if not. Yes, yeah.
How are jurisdictions looking at core and shell buildings with multiple TI buildings?
So the question is, how are jurisdictions looking at core and shell and then the future TIs? So the core and shell, well, depends which jurisdiction. BC, Alberta. Okay, so Alberta, When you're doing a core and shell, you have to demonstrate compliance with NECB. All future alterations within that building have to demonstrate the compliance with NECB and also demonstrate that they have not made the base building NECB compliance worse. So if you're doing a TI within a space, and that example I'd used earlier, and we are designing to a maximum of 7 watts a square meter, because code allows 9.7 for that office space, but the the team on that base building decided it's going to be 7 to achieve some offsetting. When we design our TI, we have to demonstrate we have not exceeded the base building targets that were put in place. If you do, then you have to demonstrate how are you going to make the overall project better. So that's the approach that they're taking. Each one separately, but it cannot make the last one worse. Very clearly spelled out. Yes?
With reference to the trade-off and the prescriptive method,
Yes?
when looking at a trade-off, say you wanted to increase the amount of glass on one side of the building, and the trade-off that you might be able to utilize, is that restricted to only, say, increasing the R value somewhere else, or can it be applied to, say, reducing lighting output, or maybe increasing efficiencies inside the building with regards to water usage?
So the question is around trade-offs and how can it be applied. So there are discipline specific, so some can only be applied within the discipline. Discipline being lighting, solar hot water, envelope, etc. Some can be trade-off with each other across disciplines. They are not easily spelt out. There's an actual table within NECB 2011 that tells you which you can cross discipline and which stays within a discipline only. So interior lighting, interior and exterior lighting, we cannot trade off interior lighting with exterior lighting, even though it's within the lighting. But interior lighting between this space and the one adjacent, I can trade it off. So there's a chart in there. I'd encourage you to look at that so I don't convey the wrong information. Any other questions? No? Yes?
So you talked about curtain wall being a thing of the past. When we're designing buildings, is there a rule of thumb you can give us as far as a percentage of glass that would be allowed if you want to follow the prescriptive method versus a performance method?
So the question is on... Okay, so the question is on the glass. Any recommendations on percentage of glass down the prescriptive method rather than performance? May I ask what type, or both, what type of project? Generally office space or institutional projects? So right now, prescriptive method to comply and demonstrate compliance is about a 33% ratio. 30 to 33%, it's about a third. That's where you're working at on the glass before you look at you can take it up to 40, take it up to 45 or so on, but then you're down the performance path. One of the things to look at is place glass where glass is needed. Even in an institutional setting, you don't need it from floor up to ceiling. There's ways to bring that the solid partition up and reduce that number. But percentage-wise, I would start as a starting point at about 30%, and you can go up from there.
And then if you're going down the performance method, is there kind of a maximum?
So if there's a performance method, it really depends. So it depends on how big and wide. The taller, the skinnier, has a different internal gain of heat and external that comes in. And the fatter and not so tall has a different number as well. Generally speaking, it ranges from anywhere from 40 up to 55% as a rule of thumb. You get past 50 and you don't have an engineer on board, I'd strongly recommend you get a modeler or an engineer. Give us a call. We'll let you know this is dangerous. 55, 60 and above, okay, now it's, you don't want to go that close without you having some technical folks on staff. And then the other thing to remember, which I tell everybody, we can design product and we can design projects with products that are available in the market. They have a claim of certain performance metrics on shop drawings and cut sheets. We take the onus of ensuring that those metrics are actually achieved in the field. So if you take it right to the end and something doesn't quite work out because there's a defect or a failure, it's too much risk. So I always go at about 50, 55-ish. I do not recommend exceeding that, especially in Alberta. We try to recommend everybody as a starting point below 50. Yes, sir.
Same question, but as it pertains to residential.
Okay, residential, you also have to include now the balconies and the protrusions beyond the building, because the protrusion beyond the building is counted within the thermal zone. So the thermal zone is the envelope outside, which there's many ways to do it. You can pour a barrier in the middle and keep that pore separate from this pore so that the thermal doesn't extend. Or what we do in Seattle is we can attach exterior cladding and then bolt it on the outside and put in the balcony. So you've got to address the balconies. You also have to address the balcony doors. So the envelope ratio is fenestration to door. So you've got to include the balcony doors and it's about the same. It's about very similar as what we have experienced in both types of usage. You can go a little bit performance-based. Prescriptive is still about 30, 33. Yes, sir.
One question about the coverage. In say an industrial building, you have part of its office
Yes.
and part of its, say, warehouse.
Yes.
With an insulated metal panel surrounding it. No, other than the overhead doors, there's no other penetrations.
Correct.
Is it still 30 to 33% of the entire building, or is it of just the office that it would be restricted for glass coverage?
It's an industrial building that complies with ABC. It's a mercantile or storage type occupancy, so group E or one of the Fs. And office is your group D within the whole thing. So 10,000 square meters, 1,000 is your office. You have to treat the entire project to comply with NECB, not just the office component.
Right, so as in, like, say you made the entire office curtain wall, is what I mean.
Yes.
And the warehouse is completely enclosed in insulated metal panel.
I got it. So how do you design that project? You have to treat it as the entire component, or you can treat it as two separate components. The two separate components, if you go down the path of glass and solid, will be much more restrictive and difficult to do. If you design it as one big box, then you may be able to achieve some of those targets, because the office component in that setting is a very small portion of the entire project itself. So we've done that many times as well. If no other yes?
I just want to clarify, and you can trade off, right? So on your envelope, you can trade off the penetration ratio on one side to another. There are mechanisms within NECB that allows you to do trade-offs between different sides of your exterior exposure or envelope.
Okay. Thank you very much.